Hello everyone, let us do a quick recall on what we have learned in this chapter on binomial theorem so far. So binomial theorem actually states this. Okay, now I know at this point in time some of you might be feeling quite intimidated, thinking how can I actually go about memorizing this theorem? Don't worry too much because this binomial theorem will actually be provided to you in a formula sheet during examination. So there is a special case when a equals to 1. So when a equals to 1, this is how the binomial expansion will look like. Okay, a point to take note is that n is a positive integer. Now let us also recall what are the things that we have learned to do with the application of binomial theorem. So with binomial theorem, we have actually learned how to perform binomial expansion taking this form. Okay, we have learned how to perform binomial expansion taking this form. We have also learned how to find the first p terms in an expansion and also to find the coefficients of a specific term in an expansion. So what will we be learning in class today? Okay, we will be introduced to a general term formula where it actually allows us to find the kth term. For example, if I want to find the fourth term in a specific, if I want to find the fourth term in a binomial expansion, or if I want to find a specific term, for example, I want to find the term that contains the x cubed term, or even to find the coefficient of a term in a binomial expansion. Okay, so let me introduce you to the general term formula. So in the expansion of power n of a plus b, the r plus 1th term is this. Okay? So in this session, we will be looking at 4 examples on how we can actually use general term formula. So let us begin with our first example where we are going to use the general term formula to find the kth term. Okay, so in this question, we are supposed to find the 8th term in this expansion. So given this expansion, the first thing that we need to do will be to identify what is our A, our B, our N, and our R. So in an expansion like this term will be your value of A, your B, your N. Okay, so since the question wants us to find the 8th term, if we recall your general term formula, my R plus 1th term takes this. So if I'm looking for the 8th term, that means my r plus 1 equals to 8, giving me my r to be 7. So once I have identified my a to be 4, my b to be half x, my n to be 13, my r to be 7, we can then now find the 8th term. So this is how a general term formula looks like. So our 8th term will be 13 choose 7. Okay, your a is 4 to the power of n minus r times b to the power of r. Okay, so this part you may evaluate using your calculator and we'll simplify a little. So for this half x, right, we can actually separate the constant from the variable. So we can see it as half times x, so which is why it's half to the power of 7 times x to the power of 7. So by simplifying this part of the constant, we will have 54912 x to the power of 7. We will now move on to example 2, where we're going to make use of the general term formula to find a specific term in an expansion. So the question is, in this expansion, we need to find a term that contains x to the power of 9. Okay, we're going to make use of our general term formula over here. Okay, so with that, let us identify my A, my B, and my N. Okay, because as of now, the value of R is still unknown, so I'll leave the expression for the general term to be in terms of R. So I'm going to substitute my N, my A, okay, my N, and my B accordingly. Okay, so we will need to recall a little on what we've learned in law of indices as well. So I've written down some of the laws that you can recall. So this part here, we will actually simplify the power. That gives us x to the power of 24 minus 2r. So as for this 1 divided by x, I can actually re-express it as x to the power of negative 1. So when x to the power of negative 1 is being powered to r, I'll have x to the power of negative r. Okay, so if I were to simplify, notice that both bases are the same of base x. We can actually combine the power by summing the power. So this will be the new power, and upon simplifying, this will be my general term. Okay, so right now I need to find the term that contains x to the power of 9. So I need to find the value of r by comparing power. So if I need to find the term containing x to the power of 9, that means that this part of my power here, 24 minus 3r, I can actually equate that to 9. So upon solving, I'll have my r to be 5. So now that I have known and I found out what is the value of r, I can then find out what is the term in x to the power of 9. So I will substitute my value of r to be 5 back into this general term expression over here. Okay, 12 choose 5 times x to the power of 9. So this part of the value, we can actually use the calculator to help us evaluate. So the term in x to the power of 9 is 792 x to the power of 9. We will now move on to example 3, where we will learn how to find a specific term in an expansion that involves an independent term. So let us now take a look at example 3, where I'm supposed to find the term independent of x in this expansion. Now, before we move further, probably we need to first understand what does term independent of x actually means. So the term independent of x actually refers to the constant term, or basically just the term that contains x to the power of 0. Okay, so we will now make use of this general term formula. Okay, and having identified this to be a, my b, and my n, okay, take note, your b over here is a negative x, so we're going to substitute my a, b, and my n into this general term. So similarly, my r value is an unknown, so I'll just leave my general term formula in terms of r. Okay, now upon substituting, okay, I'll need to remind myself, okay, that I'll need to separate the term, okay, I'll need to separate the constants from the variable. So let's look at this term over here. Okay, 1 divided by 2x squared. If I were to separate the constant from the variable, I can actually see it as half times 1 divided by x squared. So which is why I have got half to the power of 9 over r, sorry, to the power of 9 minus r, 1 divided by x squared to the power of 9 minus r. Okay, then for this part here, negative x, I can actually split it up as negative 1 times x. So I'll have negative 1 being powered to r, x to the power of r. Okay. Now take note that you need to bracket out your negative 1. Okay, so with that, let us simplify a little. We can actually re-express this part here, 1 divided by x squared as x to the power of negative 2 being powered to 9 minus r. Okay, so this part here, simplify a little. I've got x to the power of 2r minus 18. So right now, I will aim to group all my constants together, my constant side by side, my variable in terms of x side by side. Okay, so this part over here, I can further simplify to be x to the power of 2r minus 18 plus r. Okay, so upon simplifying, this will be my general term. So if I want the term to be independent of x, okay, that means the power of my x term here that I am going to consider will be power 0. So which is why I'm going to let 3r minus 18 to be equals to 0. And for me to solve further, my r is 6. So if I want the term independent of x, okay, I will substitute my r value of 6 into this general term over here. Okay, giving me 9 choose 6, half to the power of 9 minus 6. Okay, negative 1 to the power of 6. So I can actually evaluate using the calculator, and that gives me 10 and a half. We will now move on to the last example of the day. Example 4, where we're going to find the coefficient of a term in a binomial expansion. Okay, so let us take a look at this question. Okay, I'm supposed to find the coefficient of the term x to the power of negative 4 in this expansion. So basically, we need to find the value beside the term x to the power of negative 4. Okay, so we're going to make use of our general term formula. So this is my a, my b, and my n. So I'm going to substitute my a, b, and n into my general term formula. Okay, so remember the rule is to always separate the constants from the variables x. Okay, so in this case, now because in this term there isn't a constant, it is actually 1. So we'll just do the splitting over this term here. So if I were to split this up, I can see it as negative half times 1 divided by the cube of x. Okay, so that means the whole of negative half is being powered to r, 1 divided by the cube of x powered r. Okay, so let us simplify a little. For this, we can actually rewrite it as x to the power of negative 3, okay, being powered to r. So same thing, okay, we'll move our constants to a side and then we'll aim to group all my variables in terms of x together. So we're going to put them side by side over here. Okay, so because they've got the same basis, we are going to combine their power by taking the sum. So that gives me x to the power of 8 minus r minus 3r. Okay, so with that, we can then simplify this part to be x to the power of 8 minus 4r. Okay, now if I want the term that contains x to the power of negative 4, I will next need to find the value of r. So I'm going to compare the power. Okay, so that gives me 8 minus 4r equals to negative 4. So upon solving, I have my r to be equals to 3. Okay, so in order for me to find the coefficient, remember coefficient, it is actually the value before the variable x. So I don't need to consider this part over here. I'll just need to consider this part here because this will then be the coefficient of my x to the power of negative 4 term. So I'll substitute my r to be 3 in. Okay, so I've got 8 choose 3. Okay, negative half being cubed. Okay, so with your calculator, you'll then be able to find the coefficient of the x to the power of negative 4 to be negative 7. Okay, I hope with these 4 examples shown and illustrated to you, okay, you will find this part on the use of general term formula, okay, helpful. Thank you.